Hello connections, welcome to this video. In this video we are going to explain the IDs flowers classification on the dataset IDs. This is a part of the data science internship offered by Let's Grow More. So yeah, let's get started with this. So first of all, what we will do, we will import the necessary libraries required for the program. So we are importing pandas, numpy, matplotlib, seaborn, and few necessary libraries from sklearn as well for the processing part. So first of all, what we will do, we will read the dataset from the given link. The link is given here also, the dataset link. So we are importing the data from the link and changing the names of the columns as written here: sepal length, sepal in centimeter, petal length, petal width in centimeter, and those and defining the class. So we are loading the dataset here, and we are first of all printing the head of the data. We shall print the first few rows of the dataset. So here are the values and the first few rows, and we are checking the shape of the dataset. So it is 150,5. It is the shape of the data frame. Then what we will do, after we have loaded the data and know the basic details, we will visualize the data. So we are using seaborn library. We are using SNS scatter plot to plot the graph between sepal length in centimeter and petal length in centimeter, as well as similarly simultaneously we are plotting sepal length in centimeter and petal width in centimeter. Basically this is the plot of the length and width of petals and sepals respectively with graph. Now we are pair plotting the graph. As you can see here, we are categorizing the classes IDs setosa, IDs versicolor, and IDs virginica on the basis of sepal length, sepal width, and simultaneously with petal length and petal width as well. You can see these are the different graphs obtained. So now next we will do the heat mapping of our data frame. So here is the code of here is the command line of that heat map: sns.heatmap data frame.chord annotations equal to true. So here is the heat map of the data frame. As you can see, these are the values. You can check it on later in the GitHub link I will provide in the along with the video. Now what we will do, we have visualized the data. Now we will start building our model and we will train and test the data. So from sklearn we are importing the label encoder library. We will use it in our dataset. So we are renaming df class, and we are transforming it into df class. Means we are using this function from the label encoder to transform it, to fit and transform it in the data frame. So here is the result. As you can see, from head means after transforming, this is the basic result of the head. As we saw that first few rows are printed. Now we will do, we will split the dataset into training and testing data sizes respectively. As we all know that the training and training dataset has to be larger than the train. So we are splitting it into 80:20 ratio. As you can see, this is the code from sklearn dot model selection. We are importing the train test split. This is the function we will use to split the data. We are dropping the columns equal to class for generating the x row, and we are only storing the class values such as id setosa virginica in the y column, and the x column, except the class all the values are stored. So we are splitting it into x train, y train, and all those training test data into the 80:20 ratio, as you can see here. Now first of all we will apply logistic regression. So from sklearn we are importing the logistic regression, and we are fitting the data according to logistic regression in x train and y train. As you can see, here are the details of logistic regression of the function, and the accuracy fortunately has come up to 100%. So here is the command line to check what is the accuracy: model.score. and we are multiplying it by 100 because it's the values come in decimal, so to round off we will multiply it by 100. Next we will use the k nearest neighbors classifiers to get the accuracy of we implement this in different algorithm compared to logistic regression. Means we have already implemented logistic regression, so why not let's try another algorithm. So we have implemented here k nearest neighbors classifier. So same formula, model dot fit x train y train, and just the difference will be here. It was logistic regression, model equal to logistic regression, and the model here is k nearest neighbor classifier. This is the just the basic difference. So and the same command lines, model dot score x test y test into 100. So the accuracy of the k nearest neighbors is a bit low, that is 96.67%. You can round it off up to 97%. So it's not that bad, but it is definitely lower than the what it came in case of logistic regression. You can definitely try out to get some different values, changing the pre-processing values and all. So and the last algorithm what we will use is that decision tree classifier. So the formula is all the same for all these algorithms, just the name of the algorithm is changing, the function is differentiating, and all those are same, model dot fit extend y10 and all those are same. In the case of decision tree classifier also, it is has come out to be the same classifier as of logistic regression. So this is also a bit less than the this also came out to be as bit less than the logistic regression, as it came 100, and the decision tree and the k nearest neighbor came as 97% after rounding off. So thank you for watching this whole video. Hope you have a great day. Cheers.